so simplifying radicals day 2. Let's start off with number 1. We have the square root of 5 over 8. If you have a fraction, guys, underneath the radical, what it really means is the same thing as the square root of 5 divided by the square root of 8. Okay? Which tells you that you have a radical in the denominator. And you're not allowed to leave a radical in the denominator, right? It's not simplified. It's kind of like leaving a fraction not reduced, okay? Way later in calculus, you get into problems that are so mathy, I guess, they're so high level that they will let you leave radicals in the denominator. But for the most part, unless you're these very specific types of problems, they want you to, they call it rationalize the denominator, okay? Get the radical out of the denominator. So in order to do that, I've got a root 8. I need to multiply it by something that will cancel the radical out. So because it's a square root, it just means you need 2 of them. Because if you think about this, the square root of 8 times the square root of 8 actually gives us, what, the square root of 64, right, which is 8. You see how it drops it? Okay, it's because it's the square root. So 2 of the same, square it, and by taking the square root, you undo it. Okay, so you multiply, whatever you do to one, you have to do to the other. Because essentially, the square root of 8 divided by the square root of 8 is just 1. So really, you're multiplying the whole fraction by 1. Right? You're just making it look a little more, it's making it look different. So the top, root 5 times root 8 is root 40. In the bottom, root 8 times root 8 is just 8. But you can break up 40, right? We've done plenty of that today already. 4 times 10. So you end up with 2 root 10 over 8. Can I simplify it any farther? Yeah, the 2 and the 8 reduce, correct? 2 fits in here once and 2 fits in here 4 times. So the answer is root 10 over 4. Now, guys, you can't take a 2 out of square root of 10. Square root of 10 is actually, if you think about it, 3 squared is 9. So this is about 3. 2 doesn't fit in. Okay? You can only take it out of the lead when it's multiplied by. Number 2. Square root of 8 divided by 3. Square root of 8 divided by 3. If you have a fraction under the radical, first thing to do is rewrite it. It's the same as root 8 divided by root 3. To rationalize the denominator, how are we going to get that root 3 out? Multiply by what? Yeah, multiply by root 3. Whatever you do at the bottom, you have to do the top. Because essentially you're just multiplying by 1, so it's different. So you end up with root 24 over, this is actually the square root of 9, right? Root 3 times root 3 is root 9, which is how much? Root 3, just drops it. Right. Simplify 24 is 6 times 4. So you have 2 root 6 over 3. Can anything be simplified? No, you're done. Good. Root 3. 6 over 4 plus root 2. Now this one's a little messier, right? Because if you're looking at it, you have 4 plus root 2 in the denominator. So you can't just multiply. Look guys, if I tried to multiply by root 2, and I distribute it, I'm going to have 4 root 2 plus 2. Yeah, it drops that radical, but now I still have a problem here. It doesn't work. Okay? So you have to do something different. Does anybody already know what you're supposed to do? Do you know how to get rid of that? You multiply by something and it starts with the letter C. It's kind of weird. It's called multiply by the conjugate. Okay? So let me talk about something first. If I gave you, and we've talked about this quite a bit, x plus 3 squared, that really means x plus 3 times x plus 3, right? which is x squared plus 6x plus 9 when you FOIL it out and combine that term. Right? Okay? But that's, if I wrote something like this, x plus 3 times x minus 3, this is very special, isn't it? Because what happens? If they are exactly the same, and one has a plus, and one has a minus, what happens to the middle terms always? They cancel. Good. Yeah, they go away. These are called conjugates. Okay? We never called them that, but, sorry. We've not used that expression yet, but that's what they're called. The middle terms go away and they're called conjugates, right? And what you can do, the fast thing of this, is you can take the firsts and multiply them together to get x squared. Isn't that what we do? And then what's the other part? How do we find the last part? We multiply the lasts together to get negative 9. Isn't that correct? When you do conjugates, we know the middle terms are going to cancel, so there's no reason to FOIL. We can just do first and last and done. It does not work with this problem here. First and last wouldn't work. First and last would give me x squared plus 9, and that's not true. Right? It only works if you have the same thing, one positive and one negative. Do you see the difference? Okay, well that's what you're going to use to get rid of this root 2. Because if you think about this, if I multiply this by 4 minus root 2, right? Instead of taking a root 2 and FOILing it, it would mean I multiply the first together, which is 4, and the lasts together and gives me 2. Right? Because the middle roots are you're gonna end up with a 4 root 2 and a negative 4 root 2, right? And what are they gonna do to each other? They're gonna go away. Right? So what you do for these problems is you multiply by what they call the conjugate. It's called a conjugate. And whatever you do to the bottom, remember you have to do to the top. Okay? And when you do conjugates, the shortcut is firsts. So 4 times 4 gives me what? 16. You could FOIL it all out, right? The middle terms are going to cancel and it takes a lot of work. But 4, and then what's root 2 and negative root 2 going to give me? Negative 4, which is negative 2. Okay? And then the top, we're just going to FOIL. So 6 times 4 is 24, minus 6 root 2. Then we'll clean it up a little bit, okay? This becomes 12. So now I've got 24 minus 6 root 2 all over 12. Yes, thank you. All right, guys, it's 14. I'm having trouble with simple math today. It's not my day. There we go. Okay, is that better? Now what? What fits into a 24, a 6, and a 14? A what? A 2. So take 2 out of everything. 12, 3, and 7. So your final answer is 12 minus 3 root 2 all over 7. And number 4. Root 5 over the square root of 2 plus 3. Again, you have a radical in the denominator, which is not allowed, right? And you have a binomial. How do you get rid of a binomial in the denominator? Multiply by its what? Start with a C. Fancy word. Come on, okay.
Conjugate.
Conjugate. Good. So root 2 minus 3. Okay, and when you multiply conjugates on the bottom here, the shortcut is just first and last. So root 2 and root 2 is the square root of 4, which is just 2. And then 3 and negative 3 is negative 9. And on the top, you're going to have to FOIL, or distribute. Just root 10 minus 3 root 5. the top cannot be cleaned up any, so it's just going to be root 10 minus 3 root 5. And then 2 minus 7. 2 minus 9 is negative 7. Number 5. Are you ready? This is 5 plus root 3 divided by 4 plus root 3. Again, binomial in the denominator. So let's multiply by its conjugate, which would be 4 minus root 3. In the denominator, that's going to give us 4 and 4. Remember, firsts and lasts. So you do 4's together and the root 3's together. So 16 minus 3. What about the numerator? Good. Good. Kids are going to want to do first and last in the numerator. Right? Because we've just been first and lasting everything we've done, right? So you just think, well, we've been doing it, go with it. No, look at the numerator a little better. That's not going to work. Those are not conjugates, right? They're not exactly the same. It's just a binomial and a binomial. You're going to have to FOIL that. Okay? You have to FOIL the numerator. To FOIL those two. So, go for it. 4 and 5 make 20 minus 5 root 3. Doesn't matter what order you put them in. Plus 4 root 3 minus 3. Now clean it up. The 20 and the 3 make 17. So 17 minus root 3 over 13. And that thing simplifies. Or if you have negative root 3, guys, plus 17, it's the same thing. Number 6. 2 root 5 minus root 2 divided by root 5 plus root 2. The denominator is 5 minus 2. And FOIL the top. Give me, okay, the first part's kind of the hardest. I get 2 root 25, which is how much actually? 10. The rest of it's pretty straightforward. The 10 and the 2 go together to give you 12 minus 3 root 10 over 3. Is there any way to cancel?
Yeah.
The 3 has to fit into everything. In order to cancel, it has to fit into all 3. And it does. So you're going to, 3 fits in here 4 times, 1 and 1. So the final answer then would be 4 minus root 10. And it's over 1, so you don't even need it over 1. You can just drop the 1. Number 7. Root 6 minus root 10 over root 10. This one looks easy, but I'm picking this one because at the very end of the problem, kids want to do something wrong. So try it. Don't make a mistake at the end. It's a good one. Probably pretty good till you get to the very end, and there's one little mistake that kids tend to make. Okay, did you get this? Can I keep going or do I stop? That's the question. That's what kids mess up, is right here. They get it all the way to here and they do something wrong. Either what do I do or what do you think kids do wrong? Can you diagnose what kids do wrong here? Divide the radical. Okay, what else? Don't take out the 2. Okay, so let's take out the 2. That's a good decision. Alright, so if I take out the 2, I'm going to have root 15 minus 5 over 5. Now what? What do they do wrong here?
Divide by 5.
Kids want to, this is the answer, okay? Kids want to try to cancel this. Okay, but remember, you can't cancel and make that 1. It doesn't become 1 unless you can reduce the 5, unless there's a 5 in all of them. Okay? You can rewrite this if you want to root 15 over 5 minus 5 over 5. There's really no reason. Okay? And then this reduces to 1, so some kids will do that, put root 15 over 5 minus 1. But there's really no reason to do that, because if you make a mistake from here, which is the correct answer, and you actually do some math error wrong here, then you've lost points for no reason. But you cannot cancel this. This does not become root 15 minus 1. Y'all see it? A 5 would have to be with all 3, and kids tend to do that just by accident. But that says 5 divided by everything, not just the 5. If I cancel, then it's gone. Okay? So be careful of that. Alright, we have one last type of problem. Okay? And it's the cube root of a fraction. We haven't done that yet. We've done square roots, right, which are very easy. These are a tiny bit harder. Now, the cube root means that we have the cube root of a 5 divided by the cube root of a what? 4. So, if you struggle with this at all, write yourself a few notes. So, the first thing to do is to rewrite it. It's probably the easiest part. then we have to multiply it by something, right? Because we need to get this radical out of the denominator. So you've got to now decide what goes in this box. What am I going to multiply it by? Now I know I'm doing what kind of roots right now. What are the roots I'm using? Cube roots. So we know they're both cube roots. We just don't know what. Okay? So if you want to write yourself a note, you can. Right? But what you need to say is, how do I write this? 4 times some number. That's this number. So 4 times a number. Okay? That gives you a perfect cube. In other words, the number that goes here is 4 times this number is going to give me a perfect cube. Look over at my perfect cube. So what's my first perfect cube? No, 8. Right, my first perfect cube is 8. It's 2's the answer, right? So what do I need to put here so that I'm going to get 8? Because you know I'm going to multiply these together. So the cube root of 4 times the cube root of what? 2. Okay? And whatever you do the bottom, you have to do the top. Now let's check it. So in other words, what I just said, listen, I'm saying what number, the number that goes here, I say the cube root of 4 times the cube root of what number gives me a perfect cube. So 4 times what gives me one of those cubes over there. So I said, okay, 4 times 2. Isn't that going to give me a perfect cube? Sure, it's going to give me the cube root of what? 8. And does that drop the radical? Absolutely. What's the cube root of 8, guys? 2. Now go to the top. The cube root of 5 times the cube root of 2 is the cube root of 10. So that stays. That one was kind of tricky. Let's try another one like it. We're going to problem 11. Here's the 4th root of 3/8. The 4th root of 3/8. What's my first step? Rewrite it. So the 4th root of 3 over the 4th root of 8. First step is rewrite. Your second step is to fill in the box. And you say, don't call it out loud, but read the directions from above it and see if you can figure it out. This time we're dealing with 4th roots, so look at your 4th root column. The 4th root of 8 times the 4th root of, I want to get what? What number am I trying to get up there? I know I'm going to multiply these. I'm trying to get 16, right? So the 4th root of 8, because I know that 2 to the 4th power is 16. I know that. So the 4th root of 8 times the 4th root of 2 gives me the 4th root of 16. And then I can find it. Whatever you do at the bottom, you have to do the top. So the 4th root of 3 times the 4th root of 2 is the 4th root of 6. This can be simplified to give us 2. So 2. Be careful. Be sure your 4 is really close to the radical and up high. You don't want it to look like 4 times root 6. It's the 4th root of 6. Number 10. Same kind of thing, but with variables. With the cube root of a squared over b. The cube root of a squared over b. Rewrite it first and figure out what the denominator needs. Think about this. Know they're both going to be cube roots. and I'm at B. What needs to go here so that I'm going to get a cube, a perfect cube? So B times what number is going to give me a perfect cube? And you can write that down. You can say B times what value will give me a perfect cube. And that's what goes there. What's it going to be? B what? B squared. I need 3 b's, don't I, to be a perfect cube? So B times B squared is B cubed. And the cube root of B cubed is B. But whatever you do to the bottom, you have to do to the top. So now take a look at this. The cube root of A squared times the cube root of B squared is the cube root of A squared B squared. Which that doesn't simplify, so you're just done. Last one, problem 11. 28 divided by the cube root of 3. Last one. Okay, 3 times what value is going to give me a perfect cube? Look at your perfect cubes. Right, I know that 2 cubed is 8 and 3 cubed is 27. So 3 times what is going to give me a perfect cube? 9. So I'm going to put a 9 here and here. So the cube root of 3 times the cube root of 9 is the cube root of 27. 28 is the cube root of 9 goes here. So you have 28 times the cube root of 9 over the cube root of 27 is 3. And you're all done. You can work on your assignment. Please be sure you finish your assignment. You'll need to practice.